Good afternoon. I wanted to cover a particularly challenging type of problem. I wanted to show you what your capabilities are with solving equations with fractions. How we go about the process of using the LCD to cancel fractions, what that looks like in a particularly challenging type of problem. So I think once you see this example, it really will open up your minds to realizing that as long as you're identifying the number of terms you have and then identify the LCD, you can truly multiply every term by that LCD to cancel any fractions that you may have. Remember that this technique works for equations. It also works for complex fractions, but you won't see that until intermediate algebra. So if you are in elementary algebra, stick to the fact that you will use this technique when you have equations with at least one fraction. So let's take a look. Here we have 3x minus 4 all over 5 minus x plus 6 over 2 is equal to negative 2x plus 7. I want you to recognize right off the bat that we have 1, 2, 3, 4 terms in this entire equation, which is totally fine. We could have had 10 terms if, the problem demanded it. So it's not a big deal. In order to progress through this problem, my recommendation is to use the LCD to cancel fractions. So a lot of times we accidentally say, oh, okay, well, we got to find a number that goes into 5, 2, 2, and 7. That is not correct. This negative 2x is written over a 1. This 7 is written over a 1. So technically, we want to find a common denominator for 5, 2, 1, and 1. Looking at all the denominators here, I recognize that my LCD is in fact going to be 10. So what we're going to do now is we're going to place each term in parentheses. I always like placing the term itself in parentheses. You should always follow this procedure. We're then going to multiply every term by that LCD, by that 10. I want you to consider that it means we are multiplying every term by 10 over 1. When we say we're going to multiply by the integer 10, we're referring to that 10 over 1. The beautiful thing about multiplying by that LCD is that now we can simplify. Recall that when we multiply fractions, we're going to reduce numerator for denominator. So I'm going to divide out a common factor. From 10 and 5, notice my common factor is 5. So I'm going to divide 5 from both of these. 5 goes into 5 once, 5 goes into 10 twice. Notice what I am left with, 2 times 3x minus 4. I'm actually going to rewrite it before I distribute. The reason for this is I don't want to lose track of any signs. So we want to rewrite it first. That's going to be the best strategy for you. For our second term, notice we have 10 and 2. We have a common factor of 2. Let's divide that out. 2 goes into 2 once. 2 goes into 10 5 times. And notice what I'm left with, a minus 5 times x plus 6. So I'm going to write that exact expression right next to my first term. Keep in mind here that the error in which students end up having is here with this negative. What I've seen before is students will distribute the 5, but they'll forget that they're actually distributing a negative 5. So if we rewrite the problem, we won't make that issue. We won't make that error, excuse me. We'll actually distribute the negative with the 5 throughout the set of parentheses. Let's finish this. We have equals. Now notice we have 10 times a negative 2x. You're not going to reduce because they're both numerators. Recall that when we multiply fractions, we're allowed to reduce numerator for denominator, never numerators. So 10 times a negative 2x, that's simply negative 20x. And then 7 times 10, that's simply 70. At this point, this problem becomes a lot nicer because we have no more fractions. So we're just going to go ahead and distribute throughout. We're going to do this carefully. We get 6x minus 8 minus 5x minus 30. We're going to be very careful with those signs, right? Is equal to negative 20x plus 70. Before I opt to move any terms from one side of the equation to the other, I'm always going to combine like terms on the same side. So for instance, notice I have 6x minus 5x. That's going to be a positive 1x. I'm not going to write the 1 in front, it's implied. Next, I have a -8 and a -30. When we combine those, we get a -38. And that's going to be equal to, sorry about that, my pencil is ripping through my paper. I'm writing a little too hard. So x minus 38 is equal to -20x plus 70. My advice is to try to keep your variable terms positive if possible. So I'm actually going to add the 20x and bring it over just to make this into a positive value. So opposite operation to move to the opposite side of the equation. Also consider that you can only add or subtract terms to move them. So since this was a -20x, I'm going to add 20x to move it over to the left-hand side, to move it to the opposite side of the equals. That gives us 21x minus 38 is equal to 70. Notice I moved a term from the right to the left. Chances are I have to move a term from the left to the right. And in this case, we do. I'm going to add the 38 to both sides so that I can isolate my term with the x. So I have 21x is equal to 108. Last step, I'm going to divide both sides by 21. Now, we do not want to turn this fraction into a decimal. Instead, we actually simply just want to reduce this fraction. Notice that in this case, we see that 108 and 21, these are both divisible by 3. If that seems a little shocking to you, like how did I know that these are both divisible by 3? Well, consider the numerator. 1 plus 0 plus 8 is 9. 9 is a multiple of 3. Because 9 is a multiple of 3, 108 is divisible by 3. With 21, if we know our factors, we know that 21 is also divisible by 3, but also keep in mind 2 plus 1 is 3. That works for our threes, how we determine if a value is divisible by 3. So I'm going to take 108 divide by 3, that gives me 36. I'm going to take 21 divide by 3, that's going to give me 7, and that is my final answer. Okay, make sure that you reduce your answer as far as you can. You always want to reduce your fractions. And of course, use this technique anytime you have at least one fraction in your equation. And hopefully that helps. Bye.